I'll give a little bit of an overview on Enteric, and I think the prior summary was perfect in terms of the major issues, but a little bit about, first, before we get started, AgNext. You'll hear a little bit more about this from Dr. Kim Stackhouse-Lawson, our director, tomorrow. But AgNext is really unique because we're focused on sustainable animal agriculture from a holistic perspective. So I'm going to talk to you today about that kind of carbon tunnel vision of just talking about enteric methane, but we focus on a whole range of issues, collaborating with great colleagues like Dr. Derner from USDA ARS, and really focused on the social, economic, and environmental components of sustainability, right, from that whole scale perspective. Another key thing about our facility and our opportunities at AgNext is really that strong industry partnership and this facility that we've been able to create over the last couple of years, the Climate Smart facility at AgNext. And what's unique about it is for both confinement feeding and for pasture cattle, we have the capacity in confinement to measure 300 individual animals at once with green feed units and individual feed intake. And body weight gain, and this is really primarily focused on beef cattle or non-lactating animals. And then for the grazing components of the industry, have a couple of the green feed units on trailer units to look at grazing cattle emissions, which is could be a whole nother session on the challenges of measuring in those environments, right, and getting those systems to work. But again, really strong partnership and the results of $1.1 million of investment from the industry to actually drive towards solutions in this space. So just thinking about the actual producers and the actual folks in the value chain putting their investment into this to actually figure out how they can better baseline their emissions and come up with solutions that work. Part of this is, I think, again, the conversation that just happened in terms of some of the limitations with additives is really important. And part of it is just the variation that we observe within animals that are fed the exact same diet. So with what we're looking at on the slide here, I know the font is small for the back of the room, but I'll just kind of walk through what this is. This is an experiment where we were looking at a different feed additive, but what was really fascinating is these animals were all fed the exact same diet from a common ranch of origin. And when we look at what we would call residual methane emissions, so kind of like the concept of RFI for feed intake, right? We're predicting methane emissions based on body size and based on dry matter intake, and then looking at those animals that emit more or less than expected based on their cohort. And within that group of 180 animals, looking at the tails, we have a 70% difference in methane emissions, right? Which is huge. So again, we can talk about additives, and we should think about how those additives, the great points that have been brought up, potentially have different actions in these different animals that have distinctly different rumen microbiomes, right? So that's always one of those considerations, and adding some of that complexity to this whole discussion in terms of how this stuff will work. Another component of it is thinking about the economics of feed additives, right? So just as we would talk about all those components of documentation, the practical applications of feeding, some of the points that were brought up earlier about thinking about actually trying to formulate rations precisely on large dairies or large feedlots, right? There's a lot of management challenges that come into play. Part of that is also thinking about the economics of using these feed additives in a U.S. context where we're looking at voluntary markets or other means of funding feed additives that maybe have no productivity benefit. So these two tools are simple, but they are available as spreadsheets for download. And the key point for these is kind of summarized on this slide here. So if we just look at a hypothetical scenario where we have a feed additive for dairy cows that has no effects, positive or negative, on productivity for dairy cows, say it reduces our emissions by 20%. What we're looking at on this chart is, on the x-axis, our carbon price that would need to be received by the producer. So taking into account all the middlemen in the middle, right? The actual price they would receive. And then on the y-axis, kind of their net return. And the key takeaway there is, if we look at those different costs in terms of 5 to 15 cents per cow per day, meaning that's how much the additive would cost, there's quite a range in those break-even carbon prices. And also those are all far above where voluntary carbon prices are today, right? So not to dump cold water on the whole thing, but we need to have those technical solutions. We need to think about all those points that have been raised, the safety, right, the welfare of the animal, all those components, the efficacy. But we also have to think about how practically will this be fed and how will it make economic sense for producers to adopt in those situations where it makes sense to use feed additives. So with that, thank you very much, and happy to join the panel discussion.